In this video, you will learn about rational expressions. Now, what do we mean when we say a rational expression? Well, what we are referring to is a fraction where the numerator and denominator are polynomials. So for example, maybe we have x plus 3 over 5, or x squared plus 4x minus 2 over x minus 2, or 8 over x squared minus 5x plus 12. All of these would be rational expressions. Now, when dealing with rational expressions, be aware that we have what's called the domain of rational expressions, meaning what numbers can x equal. All right, so typically x can be any number, except for realize that the denominator can never equal 0. All right, so for example, right here, we have x minus 2 in the denominator. We are limited because this denominator cannot equal 0. All right, so what we can do is realize that x minus 2 cannot equal 0. We solve this for x by adding 2 to both sides, so x cannot equal 2. So in that case, the domain is limited to any number except it cannot equal 2. So the domain, again, is the set of all real numbers that can be used in place of the variable. All right, so and as we mentioned, it excludes numbers that will cause division by 0. All right, so when we write the domain, when we write the domain being x is not equal to 2, as we see right here, what that means is that x equals all real numbers except x cannot equal 2. So instead of writing that all out in English, that whole entire phrase, we can just write it shorthand by saying x cannot equal 2. All right, so that is the domain. So for any expression, we would have to set the denominator equal to 0 to see what limitations do we have. So with rational expressions, we have different properties to be aware of. So assuming that we have q and s, where both q and s are not equal to 0, we have our first property, which is the property of equality. So two rational expressions are equal if and only if we can cross multiply to get equal answers. So for example, if we multiply p times s, that must equal q times r. All right, so that would be a property of equality. And then we have what we call equivalent expressions, where if we have a fraction, such as p over q, we can multiply the numerator and denominator by any number, and here multiplying by r. The only exception is r cannot equal 0. All right, so it can equal any number except for 0. And then another property is when dealing with signs. So if we have a negative sign, so say we have negative p over q, the negative sign could go on the outside like this, or it could be with the numerator, or you could write the negative with the denominator. So all three of these expressions are equal to each other. So now let's move on and learn how to simplify rational expressions. All right, so to simplify, we can factor the numerator and denominator if necessary, and then from there we can see if any factors are in common. And then if they are, we can simplify by dividing out those common factors. So for example, here we have 2x squared minus 11x minus 21 divide by x squared minus 2x minus 35. Now I should note that at this point, we are assuming you are proficient in factoring. So if you're not, maybe refer back to the previous lesson to get some practice. But at this point, we're going to kind of gloss over the factoring process and just show you what you're going to get. So the numerator, when you factor, you would get 2x plus 3 times x minus 7. And then the denominator, you would get x plus 5 times x minus 7. So notice they both have x minus 7 in common. So what I can do is divide top and bottom by x minus 7, which will have the effect of canceling out. So what we're left with is a 2x plus 3 on the top, and then x plus 5 on the bottom. So your final answer would be 2x plus 3 over x plus 5. So that is how you simplify. And then from here, we're going to work with different operations with rational expressions. So that would be addition, subtraction, multiplication, and division. So for addition, if we have two fractions, remember that what we do is we need a common denominator, and once you have that, then you can add the numerators together. So if you have p over q plus r over q, they have a common denominator, so I can add the numerators to get p plus r on the top, and then q would be your denominator. Same thing with subtraction, so we can replace the plus sign with the minus sign, and we have now p minus r over q. So the same principle applies for addition as it does for subtraction. With multiplication, say we had p over q times r over s. What we would have is p times r on the top, and then q times s on the bottom. So you'd multiply the numerators together, and then multiply the denominators together. And now with division, say we had p over q divide by r over s. Division is the same thing as multiplying by the reciprocal. So instead of dividing by r over s, we can multiply instead by s over r, which would give you p times s on the top and then q times r on the bottom. And realize that r cannot equal 0 and q cannot equal 0 as well. So now let's take a look at some actual examples where we work with addition, subtraction, multiplication, and division. So to begin with, if you're adding and subtracting, we need to be aware of how to find the least common denominator if necessary. So the first thing is make sure that you factor the denominators completely, and then you can write the repeated factors using exponents. And then you can find the largest power of every factor. So then the least common denominator would be the product of each product raised to its largest power. All right, so what does this look like? Well, let's say we had 4 over x squared minus 1 and 9 over x squared plus 2x minus 3. So the first fraction we can factor to get x minus 1 times x plus 1. And the second fraction we can factor to get x minus 1 times x plus 3. All right, so you look at both denominators and you see what factors we have represented. So we have x plus 1s, we have x minus 1s, and we have x plus 3s. So we need at least one of each, and if we have anything raised to a power, let's say for example we have x plus 3, let's do x minus 1 to the third power. If you had x minus 1 to the third power, what you do is you have to put a third power here. So you take whatever one has the most. So if this is x minus 1 to the third power, let's say this is x minus 1 to the fifth power. All right, we take the largest degree, so we'd have to change that to x minus 1 to the fifth power. So in this case, though, everything is to the first power, so we just take one of each. So your least common denominator would be x plus 1 times x minus 1 times x plus 3. And for these examples, we're not trying to add or subtract yet. We're just trying to find that least common denominator. Let's try another example. Here we have these two fractions. And this one is nicer because it's already factored for us. All right, so here we see we have x's. We see we have x plus 2's. We see we also have x minus 5's. So the question is, how many of each do we take? Well, looking at the x's, this one has 1, this one has 2. We take the one that has the most, so here we take 2 x's. X plus 2's, we only have 1 represented, so we just have x plus 2 to the first power. And then x minus 5's, here is the one with the most. We have 3, whereas over here there's only 1. So we take 3x minus 5's to get x minus 5 cubed. So the least common denominator would be x squared times x plus 2 times x minus 5 to the third power. Now this process is necessary when adding and subtracting, because to add or subtract we need to make sure that we have a common denominator. So here let's try an example or two with addition. And here we have 2 over x plus 8 plus 4 over x plus 1. So what we do is we first must find the least common denominator. So notice we have x plus 8s and we have x plus 1s. So your least common denominator would be x plus 8 times x plus 1. So what we need to do is convert each of these fractions into a new fraction with this denominator. Alright, so the 2 over x plus 8, we now need to have it as x plus 8 times x plus 1 in the denominator. So for the first fraction, we started with x plus 8, but we had to multiply the bottom by x plus 1. So on the top, we must multiply by x plus 1 as well. So take the 2 and multiply by x plus 1. Second fraction, again, same thing. We need a common denominator. And we started with just an x plus 1, but we also had to multiply by x plus 8. So the numerator, the 4, we also must multiply by x plus 8. So now we have our new fractions. And then we can combine by rewriting as one fraction with our denominator of x plus 8 times x plus 1. So we have 2x plus 2, and then plus, we have 4x plus 32. So you distribute, and then simplify the numerator. 2x plus 4x is 6x. 2 plus 32 is 34. And that is all over x plus 8 times x plus 1. So this here would be our final answer. And just always double check to see if we can simplify further. And in this case, we cannot. So this would be our final answer. Now let's try example with subtraction. So here we have x plus 1 over x minus 4 minus x plus 1 over x squared minus 7x plus 12. So to begin, we need to find a common denominator, and to do that we need to begin by factoring. So the x squared minus 7x plus 12, that can factor, and that would give you x minus 4 times x minus 3. And we see that typed up right here. Alright, so we have our denominator factored, and now from here we can find our least common denominator. So notice we have x minus 4s, and we have x minus 3s, and we only take one of each because the most we see at one time is 1. Alright, so we need to rewrite both fractions with that common denominator, and in this case the second fraction is already has that common denominator, so it's really just the first fraction we need to rewrite. So here we can rewrite that with x minus 4 times x minus 3 in the bottom. And notice what's changing is we started with x minus 4, but then we multiplied by x minus 3. So you must also multiply x plus 1 in the numerator by x minus 3 as well. Alright, so when you do that, alright, you're going to get, so in the numerator, we can distribute, we get x squared, and then we would get minus 3x plus 1x, which gives you minus 2x, and then 1 times negative 3 is negative 3. So we have that over the x minus 4 times x minus 3. And then don't forget, we're subtracting that with the x plus 1. Alright, so then what we can do is we can combine into one fraction. So we have x squared minus 2x minus 3 minus the x and minus the 1. So the denominator would stay the same, x minus 4 times x minus 3. The numerator, we have x squared, and then we have negative 2x minus x, which gives you negative 3x. And then we have negative 3 minus 1, which is negative 4. Alright, so now we have that. Now from here we can actually factor the numerator. So when we factor, we would get x minus 4 times x plus 1 over x minus 4 times x minus 3. And notice the x minus 4s would cancel. So your final answer would be x plus 1 over x minus 3. And that's how you take care of a subtraction problem. So we have dealt with addition, and we've dealt with subtraction of fractions. Next, we're going to work with multiplying and dividing, which in my opinion is actually easier because we don't need to find a common denominator. All right, we can just factor and then cancel. So let's try an example with multiplying. Here we have 28 minus 7x over x minus 4 times 1 over x plus 10. So the first thing we want to do is factor if we can. So notice the 28 minus 7x. We can pull out a common factor of 7. You're left with 4 minus 1x. And we see that typed up over here. All right, now we look for things to cancel. Now the only things that would maybe cancel would be 4 minus x and x minus 4. But they're not identical. All right, they're not exactly the same. So there's a technique we can use to kind of force it into being the same thing. And this works when you see a binomial like this, when you have the signs that are opposite. So like here we have positive 4 and negative x. Down at the bottom, we have a positive x and negative 4. So looking at the 4 minus x in the parentheses, what we can do is we can pull a negative out. So then in the parentheses, we would need a negative times negative 4 to get positive 4 for the first term, and negative times positive x to get negative x for the second term. So pulling a negative out would effectively change the sign. And now we can rearrange on the inside to get the x first and the minus 4 second. So the 4 minus x in the numerator, we can write that as a negative and then x minus 4. And we see that typed up over here. So now we have a negative 7 times x minus 4 over x minus 4 times the 1 over x plus 10. So now notice the x minus 4s would cancel. Now you're left with negative 7 times 1, which is negative 7, over x plus 10. And that is your final answer. So that is multiplication, and division is pretty much the same thing. All right, so here we see a division problem. You're told to divide these two fractions. And the only difference here would be with the division, that is the same thing as multiplying by the reciprocal. So you're multiplying, but then you change the numerator and denominator of the second fraction. So before we do that, let's factor this numerator right here. So we can pull a 2 out and an x out. You're left with x minus 6 in parentheses. All right, so we have 2x times x minus 6 over x plus 5. And then, instead of dividing by x minus 6 over x plus 5, we would multiply by x plus 5 over x minus 6. So now from here, anything in the numerator of either fraction can divide with anything in the denominator of either fraction. So notice x plus 5, that can cancel up here with this x plus 5. And then the x minus 6's would also cancel. So what you're left with is 2x over 1, which would be 2x. All right, so multiplication and division are pretty much the same thing. Just make sure you factor first and then cancel as necessary. Next, we're going to talk about complex fractions, which is kind of a combination of the addition and subtraction and also the division. So what this is it is a fraction whose numerator or denominator contains at least one other fraction. So it's like a fraction inside of a fraction. All right, so to simplify complex fractions, we have two different methods. So we're going to show you both methods in English, and then we're going to demonstrate what that would look like. So method 1 for simplifying would be multiply both the numerator and denominator of the complex fraction by the least common denominator of all the fractions contained in the complex fraction. So you multiply the top and the bottom by some number. Or method 2 is you can simplify the numerator as a single fraction and then the denominator as a single fraction. and then divide. So when you divide, that's multiplying by the reciprocal. All right, so we have two different options. So here we have an example, and this would be a complex fraction, as you can tell, because it looks complex, but also we have a fraction within a fraction. So we're going to illustrate to begin with by using method 1. Method 1, remember, is we need to find the least common denominator of the fractions that we see. So looking in the numerator, we have a 12 and a 4, and the denominator, we have an 18 and 36. So what is the least common denominator of all four of those numbers? Well, that's going to be the number 36. So what we do is we multiply the numerator by 36 and the denominator by 36. And we see that typed up right here. So when you do this, you distribute the 36 by multiplying to both terms on both the top and the bottom. All right, so just be careful when you're distributing. So we have 36 times 25 over 12 on the top. The 36 and 12 can divide out. You're left with 3 and a 1. 3 times 25 is 75. So that gives you 75 plus, and then we have 36 times x plus 1 over 4. So 36 would divide with the 4 to give you 1 and 9. So what we have is 9 times x plus 1, which would distribute to get 9x plus 9. So that would be the numerator. And then the denominator, we do the same thing, 36 times 1 over 18. So when you do that, 18 and 36 can divide out. It gives you 1 and 2. 2 times 1 would equal 2. And then 36 times the negative x plus 1 over 36. Here 36's would cancel. You're left with x plus 1. So we have minus x plus 1. So we have minus x, and we also have minus 1. All right, so now it's much simpler, right? All the major fractions are gone. We're left with just one fraction. And so the numerator, 75 plus 9, that would give you 84. We have 9x, so 9x plus 84, and that's over 2 minus 1 is 1. Then we have negative x, so we have 1 minus x, or negative x plus 1. And then always check to see if things can be taken further. So see if you can factor and simplify. And the numerator, you could actually pull out a 3, and we're left with 3x plus 28. But that's not going to cancel with anything, so there's no need to do that. And this would be your final answer. And we see that all typed up right here. Now let's take a look at an example using method 2. So method 2 is when we simplify the numerator and then simplify the denominator, and then we divide. So here the numerator is 9, that's already simplified, and then the denominator we need to simplify. So the denominator, the 9 over x plus 2 over 3x. All right, looking at that, we need a common denominator, which would be 3x. So the 9 over x, you take x times 3 to get 3x. So 9 times 3 would give you 27 on the top. And then plus 2 over 3x. And that can combine to give you 29 over 3x. So that was all the denominator. And we see that typed up right here. So what we have is 9 divide by 29 over 3x. So if you want to think of it like this, 9 divide by 29 over 3x, that is the same thing as 9 times 3x over 29. So nothing cancels. You can just multiply across. 9 times 3x is 27x, and then we have 29 on the bottom. So your final answer is 27x over 29. So you can use either method. you could multiply by the least common denominator on the top and the bottom, or you can simplify the numerator and denominator and then divide. So it depends on the scenario and the fractions you're dealing with to determine which one is simpler, but it's kind of up to you, whatever one you prefer. And kind of rule of thumb is if there's like a lot of fractions like we see in the first one, more than likely it's going to be simpler to just multiply by some number to get everything to cancel right away, so all the fractions would be gone. Whereas here in the second example, okay, this one is not as complex, so we can much more quickly just simplify the denominator and then divide. Alright, so that's kind of the key, and again, you can use either method, whichever one you prefer. Now, as we bring this lesson to a close, there are two more things we want to do. Here on this slide, what we are doing is we want to simplify fractions with negative exponents. And then the last slide, we're going to talk about applications. All right, so here, our example we're going to look at is a to the negative first power over b to the negative first minus c to the negative first power. All right, so remember, negative exponents, what that means is that we have 1 over something. So a to the negative first power would mean 1 over a to the positive first power. So b to the negative first power would be 1 over b to the positive first power, and c to the negative first power would equal 1 over c to the positive first power. And we see that all typed up right here. All right, so now we have this new fraction that we can now try to simplify. And again, you can use either method, method 1 or method 2. And in this case, we're going to choose to use method 1, which is multiplying the numerator and denominator by the least common denominator. So we have a's. So here we have an a, here's a b, and here is a c. The least common denominator of all three would be a times b times c. So what we can do is multiply the top and the bottom by ABC, and we see that typed up right here. And when you do that, when you do 1 over a times ABC, or ABC over 1, the a's would cancel. That gives you b times c. All right, so we have b times c on the numerator. The denominator, we take ABC, multiply it by both terms, we distribute. So we take 1 over b, multiply by ABC, and then we do 1 over c times ABC. So 1 over b times ABC, the b's cancel, you're left with a times c. And then 1 over c times ABC, the c's cancel, and you have a times b. So when we distributed, we now have AC, and then minus a times b. So your final answer is right here. We have BC over AC minus AB. And we see our final answer typed up right here. Now to finish off, we want to discuss an application of rational expressions. And there's all sorts of different applications we can use for this, and you'll see a lot of those in the homework questions. But here's just one example where we are told that the average speed for a round trip is given by the complex fraction 2 over 1 over r1 plus 1 over r2, where r1 is the average speed on the way to your destination, and r2 is the average speed on your return trip. And we're trying to find the average speed for a round trip if r1 is 60 miles per hour and r2 is 65 miles per hour. So to solve this, what we do is we just take the formula given to us and then we plug in the different numbers. So we have here r1 is 60 miles per hour, so we plug a 60 in for r1, and then r2 is 65 miles per hour, so you plug that in for r2. So we have 2 over 1 over 60 plus 1 over 65. And then from here, we can try to simplify this fraction. or I guess we could use a calculator, but our objective here is we're trying to get practice with the simplifying process. So if we're doing it by hand, what we can do is we can use either method 1 or method 2. And here we're choosing method 1, where you're going to multiply the top and the bottom by the least common denominator. So if you look at the 60 and the 65, we need to find the least common denominator of those two numbers. Well, 60 is 5 times 12, and then 12 can break down further, and then 60 is 5 times 13. So, and 13 is prime. 12 we can break down further if we want to, but it's not necessary in this particular case. So we see 5s, so we take a 5, and then we see a 13, and then we see a 12. Multiply all those together, and that's going to give you 780. So that is going to be your least common denominator. So if we multiply the top and the bottom by 780, as you see typed up right here, 2 times 780, that would give you 1,560. 780 times 1 over 60, the 60 and 780 would divide out, that would give you 13, plus, and then 780 times 1 over 65, okay, 65 and 780 would cancel and give you 12. So what we have is 1560 over 25, as you see right here. And then we can divide, and you can do this by hand to verify or use a calculator. When you divide, you're going to get 62 and 2/5, or 62.4, and the units are miles per hour. So your answer is that the average speed for this round trip would be 62.4 miles per hour. Now this concludes our lesson for today. We will see you next time.